Hi, so this is editing Stand. This has been a long project of mine. I've actually thought about it for probably about a year now. And this is something that I just recently had a chance to work on because I'm actually going back to trade fairs where I actually use my jerrycan. So this is so excuse the continuity. This is was filmed over about 2 weeks. I basically started designing it, made about had to ended up doing about two or three major revisions because my initial ideas were to use washers as like a part of check as the part of the check valve, and that pretty much turned into just turning it into a ball valve, which you'll see in a minute. Um, but thank you for watching. Please like, comment, and subscribe, and let's get back to the video.
So this is about revision 4 with the 3D printed check valves inside the PVC pipe here. And this pops about a liter every 30 seconds, so I'm getting a 2 liter a minute flow rate. This is great for scouts and campers because then you could fill up Nalgene's and Camelbacks really quick. And it doesn't take much effort to work the handle at all. Stand with 3D painting. So here's the finished jerry can pump. And so the inner tube is a 1/2 inch PVC, outer tube is a 1 inch PVC, which is a slip joint cap, and this actually ended up being a rejected seal from something else.
So day two of this jerrycan pump project. I actually tested it out last night, and I tried doing it with a set of check valves I made with a printed plunger and a washers.
So my first valves that I tried to make were here, and I tried to use just a set of washers as the check valve. These actually ended up pretty much locking up and being completely worthless. It took a few revisions, but I made each of these a set of ball valves. So inside there's a 16mm glass marble, and both these pieces go together. And so I'll show the animation later on how this works, but I'll go ahead and put this pump together and show you the pump working.
And I'll just say that it failed miserably. It actually worked better as an air pump because it was pumping air into the jerry can instead of drawing water out. And I think it was just because my design was pretty much ended up turning into a weird two-way valve. So with a with this project, you want the water to always go in one direction. And I think both the valves together were kind of canceling each other out. So, licked my wounds, and I just decided to go ahead and make a set of ball valves that are 3D printable. And so the idea behind a ball valve, let's see if I can get this to any bigger, is that there's a restriction on both ends. The ball seats here at the bottom, and either gravity or a spring provides pressure. So every time the uh, valve goes down, water's forced around the ball through the chamber and out. And when there's back pressure, that presses the ball closed. So for this, I have a fortunate supply of uh, sturdy glass. Marbles are from an old project I used to sell. I used to actually make fidget spinners with this. So instead of skateboard bearings, I made them with glass marbles. And so I went into TinkerCAD, revised everything. And if I focus on this one, make it transparent. Let's see if I can get a good view there. Let's move it over here. So the idea here is that this chamber here holds the ball, And this is just going to use gravity to hold it down, because this is going to be a vertical pipe when it's assembled. So this is the bottom piece. This way water can flow up and through. Same with this one. This one's going to be attached to the half-inch pipe. So this one has this nub here for that. And because this fits inside the pipe at the top of the piston, this is going to double as the piston. So I had to cut the channels a little differently for this. And so that's printing right now. So right now, this is about version, I want to say about 4.5 printing. I just have not had good luck with some measurements. And I've just been kind of boneheading the measurements and redesigns through. So the one on the left is the bottom one, bottom ball valve, and the one on the right is the top one. So this is printing right now in NinjaFlex TPU. And when it gets to about layer 80, it's going to pause, and I'm going to drop in the marbles to form the ball valve. And here's one I did earlier. And you can see how it works. It's just, I screwed up something on the top of the print, and it was just a little too tight at this size, but you can see here the marble will go back and forth. So this has been a work in progress just because I haven't been paying attention to my measurements, but we'll see how this works in a little bit. So I didn't film it while I was putting the marble in, but this is the bottom and top piece, and both of them have a 16mm glass marble inside. And the idea is this is going to be basically like a print in place. So it's going to print over the top and assemble the ball valve, and complete the valve as a one-piece unit. And this is going to be the piston and ball valve on the inside pipe. So this fits a Schedule 40 half-inch PVC pipe, and this one fits a 1-inch Schedule 40 PVC pipe. And so this will go in the bottom, be the bottom valve, and this will be the top valve. Alright, so a couple more days. This is about version 4 of the bottom valve. So I actually tested the pump out yesterday, and I noticed that when I was trying to draw, it would only go up a certain amount and then stop drawing water, and then it actually locked up. And so in the other valve I have a hole in the top here, but my top valve actually was shaped like this, so it was actually letting water pass through fairly quickly. So all I did is I just printed this, and then when it was done and still warm, I squeezed it open, stuck in the marble here. So I'm going to put some more Teflon tape on this, screw it in, and then secure it. So you can see how it works. Here's the ball valve closed, and then it'll come open. And you'll see how it looks in a minute.
So right now these pieces are just friction fit together. So from the 1-inch pipe, we've got a 1-inch T to a 1/2-inch T. Section of about 6 inches of 1-inch pipe with a fitting on the end. And on the inside I did put a gasket with 3D printed TPU going out to the 1/2-inch pipe with a standard 1/2-inch T to T. This is all friction fit together. None of it's glued, and I'm just going to leave it as a friction fit for right now. So with this pump, it's self-priming, so you just put it in the can and the water forces itself up and primes itself. And when I start it, I could use any length of stroke I want. And this clears about 2 liters a minute. And right now the jerry can's only about half full. And so it's using the 2 3D printed ball valves in sequence to pump water out.
Thank you for watching. This is my first time doing an animation in TinkerCAD. So please leave a comment if you like that. Also, I'm looking at other projects to do in the future and maybe some other revisions and some follow-ups. So if you would like me to follow up on any of the videos I've done previously, please leave a comment below. And if you like what you see or would like files for this, please subscribe. And thank you for watching.